We've hinted at this idea of continuity and how limits are going to give us something that really gives us a formal definition of continuity, which up until this moment you've only been able to really describe continuity as you can draw a graph without picking up your pen or your pencil. And obviously we want a little bit more formal definition than that, and limits gives us that. So we can actually say that a function is continuous at the point x equals c. So we're looking here at continuity at a point. A function is continuous at x equals c if and only if the limit as x approaches c of f of x exists, and we'll say it equals some value L, and that also happens to equal f of c. And I want to do a little sketch of a graph here so that you can see exactly how limits are going to play a role here with this definition. So let's look at x equals c. And we've said that the limit is going to equal L, and the function is also going to equal L. So let's label some sort of value L. Now then, reading this equality statement we have, if I say f of c equals L, f of c equal to L, that means I have the point CL on my graph. So I have a point right there at C comma L. The equality statement saying the limit as x approaches c of f of x is equal to L. That means that as, and this is from both sides, that as I'm approaching the value c, the function is approaching the value L. And so it doesn't matter how I'm doing it, but as long as I'm approaching L as x is approaching c, you can see right there that I can say that's a continuous function at x equals c. I'm going towards c, that's what the limit behavior is describing, and I'm equal to the value of L. I should have said I'm going towards L earlier. But you can see I'm going to L, I'm at L, and so therefore we can state that f of x is continuous at x equals c. Now then, we're going to use this definition and this idea to actually confirm or verify continuity at a point. That comes in the next topic, topic 1.11, where we'll actually confirm that a function's continuous. This lesson today focuses on the three main types of discontinuities. And you know some of these various discontinuities, whether it's a hole in the graph or an asymptote. And basically we're going to look at three types of discontinuities and describe how they fail this definition in order to describe that particular type of discontinuity.